video notes. I'm trying something different. I'm trying using the computer and the smart software instead of EduCreation, so let's see how this goes. Newton's third law of motion is the idea that whenever you have a force, that force exists between two objects, and there's force applied both ways. So when you have an object applying a force to another object, you have an equal and opposite force exerted back on the first object. And this is where you get the idea that for every action, there is an equal and opposite reaction. Whenever you push on something, that object will push back on you. And in order to make sure that we're clear on exactly how this works, here's a little phrase we can use. So if you want to find Newton's third law force pairs, always you think of your action force is the force of some object on another object. So we'll have a couple examples in a second. Your reaction force is the force of second object on first object, right? So you're just going to flip the objects. And let's look at a couple examples and see what we can do with this. All right, so your first object here, let's look at this one. You've got the action is the tire pushing on the road, all right? And if you have tire pushing on the road, that is your two objects right there. So let's go and let's fill these in. So you have force of tire on road, and so to get the reaction force, you just flip the objects. So we have the force of the road. Come on now, road back on the tire. That's your equal and opposite reaction force. All right, let's look at another one. All right, if we use the spaceship right here, all right, your rocket ship fires gas out of the back of it, and this is a useful one. All right, so the rocket pushes gas out of the back end of the rocket. That is your action force. So let's go back here. So we have the force of the rocket on the gas, and then the reaction force is the force of the gas on the rocket. Now this is helpful, all right, because the rocket is pushing the gas backwards, and then the gas pushes the rocket forwards, which is exactly what you want. All right, you want the rocket to have a propulsion system, and this is how you get propulsion. Our last one here is if you have the Earth is pulling on a falling object, okay, it's pulling on a ball. That means that your action force is the force of the Earth on the ball. And so your equal and opposite force is actually the force of the ball pulling on the Earth. All right, gravity works both ways, and that's something we're going to talk about later this week, is that gravity works both ways. The Earth pulls the ball down, but the ball also tries to pull the Earth up. Interesting. All right, so that's how you can do third law pairings. These forces are always going to be equal to each other, and they're always going to be in the opposite direction of each other. So here's an example. If the Earth pulls on the moon, does that mean the moon pulls on the Earth? Well, let's look. If we have the Earth pulling on the moon, I guess that means that you also have to have the moon pulling on the Earth. All right? So it has to go both ways. You cannot have a force that doesn't. And those forces have to be equal to each other. Right? These forces must be equal to each other. That is the definition. All right, that is Newton's third law. It cannot be any other way. And now let's look at one more application to this. All right, application is recoil. All right, if you have a rifle firing a bullet, all right, you have a small bullet and you have a larger rifle. If the rifle applies 600 newtons of force to the bullet, then what is the force applied to the rifle? Well, let's go back here. All right, so we have two forces. We have force of the rifle, 600 newtons, force of the rifle on bullet, and this force is forward, right, because the bullet is going to move forward. So you also have to have 600 newtons of force of the bullet on the rifle. All right, and the rifle gets pushed backwards, and this is your recoil. Now, even though these forces are equal, you don't notice the same effect, okay? The rifle doesn't go flying the same way that the bullet does, and that's because you can apply Newton's second law to this. All right, so if you want to find the acceleration of the rifle to actually see what's going on, then you want to use Newton's second law on that. So you want to take this, you want to take acceleration equals force divided by mass, okay? So you take that 600 newtons and you divide it by the mass of the rifle, which is 7 kg, and if you take 600 divided by 7, you get about 85 meters per second squared. All right, equals acceleration. All right, so see if you can do this next one. All right, see if you can find the acceleration of the bullet. All right, hopefully you paused it, and hopefully you figured out the acceleration of the bullet, because here goes the official solution. All right, start off the same way. Acceleration equals force divided by mass. All right, so we have that same 600 newtons, only this time it's divided by a much smaller mass of the bullet. And if we divide 600 divided by 0.05, that equals 12,000 meters per second squared. All right, that is a lot of acceleration. And why won't that go down? Boom. All right. So there you go. Even though the forces are equal, the forces on the rifle and the bullet are equal, but the accelerations are not the same because the masses are not the same. All right, those are the notes. Take care.